Hey, Algebra 2 students. We're going to talk about natural base E and natural logarithms. So we're going to be able to evaluate expressions involving the natural base and natural logarithms. And we're going to solve exponential equations. Inequalities. The inequality part will be in class using natural logs. So we have another number to add to our little family here. So these are all irrational numbers. Pi, square root of 2, and now we have the new guy. We have E. What is E? E is 2.71828, blah, blah, blah. Goes on and on. So it's an irrational number. You will actually use it a lot in calculus. We use it for compound interest and probability theory. You use it a lot in. It's named after a guy named Euler. That's all I know about it right now. We're just going to use it right now, but once you get into calculus, you'll be able to see like where actually this number comes from, and it's really cool stuff. And you'll use it a lot. So, and when we take the log base E, we come out with a natural log. This means right here, this is the natural log. So instead of writing log base E, we just write the natural log ln. So that's what we use. Kind of neat. So that's what we're going to do. We're going to be doing all the stuff that we've been doing with logs, but now with just the natural log. We're going to go all natural here. So here's just some notes from your book, what the graphs look like. Just know that the function e to the x and the natural log of x, they're inverses of each other. Alrighty? So you can read that later if you'd like. We go back to exponential growth and exponential decay, what we did in section 1. So let's go ahead and write these in log or exponential form. So here's the first one, e to the x equals 8. So we're going to write this in natural log form. We know it's going to be natural log because we're using e. So again, we're using abe. So this is kind of backwards abe here. Okay. So our base is going to be e. So it's log base e of 8 equals x. So since we have log base e, it's the natural log of 8 equals x, and that would be our answer. So what about for this one? The base is going to be e, so we have the natural log. Our answer is x, and then our exponent equals 5. Now let's write this in exponential form. We know the base is e right here. And our exponent, this is our exponent, so we have x equals, if we use abe, e to the 0.7741. What about this one here? We know our base is going to be e, our exponent is x, and our answer then is 18. So this is using the natural log and using e, natural base e, in exponential form. So now let's use the properties to simplify, to write as a single logarithm. You're going to be tested on this on the next assessment. So let's look at this first one. We know I have a coefficient out front, so that's going to come here. And so then we get the natural log of, let's see, can I move this? Yes, I can. Okay. We know the natural log of 10 to the third minus the natural log of 8. Now what happens when we're subtracting logs? What do we do with the answers? Right, we go ahead and divide them. So 10 to the third over 8 is actually 125. So we have the natural log of 125. Now, can you write 125 as a power? Sure can. We can write as 5 to the third, right? So since this is actually written as 5 to the third, you can write it as 3 natural log of 5. So if you can write as a power, just go ahead and do it. And yeah, so then we can simplify it down even farther. Alrighty. If you can't write as a power, then just leave it as is. Let's look at this next one. The natural log of 40 plus 2 times the natural log of 1/2 plus the natural log of x. So it looks like we have a lot of addition signs, so that means we're going to multiply. Here we have an exponent, so that's going to come here. So when we're adding logarithms, we multiply the answers. We have 40 times 1/2 to the second times x. Go ahead and combine these. We're going to get, what is it? 10x. Now, can you write 10 as a power? No, it doesn't come out nice. So we're just going to go ahead and leave it as is. So there you go. Properties still apply to our natural log. Now, what about solving equations with the natural log and base e? Well, you got to keep this in mind. Because the natural base and the natural log are inverse functions of each other, they can be used to undo or eliminate the other. So, for example, if you have the natural log of e to the x, that's going to equal x because these cancel each other out. Okay? And let's say you have the natural log, or e to the natural log of x. That's also going to equal x because they cancel each other out. And keep in mind that, well, why is that? Because the natural log of e, that equals 1. All right, that equals 1. So that's why that works out. So just know that they're inverses of each other, and that's how you undo the other function. So let's look at this equation here and see if we can solve it. We're going to solve for x. And what we want to do is we want to isolate this first. So let's go ahead and add 5 to both sides. Now we're going to go ahead and divide by 4. Okay, so x is still in the denominator, or excuse me, not the denominator, what am I thinking? In the exponential spot. So we have an e. How do we undo e? We take the natural log. So we're going to take the natural log of both sides. Those end up canceling out. So now we have a negative 2x equals the natural log of 2. How do we get x by itself? We're going to divide by negative 2. So when you enter this into your calculator, you're going to take the natural log of 2, close it off, and then divide by negative 2. Should end up with x equals negative 0.3466. And that would be your answer. Alrighty. Okay, so what I want you to do for tomorrow or for next class is I want you to go ahead and solve this equation. Solve for x, please. Round to the nearest 10 thousandths. So 10 thou. How do you spell thousandths? Thousandths. Okay, so that's 4 decimal places. Go ahead and do that for this in the Google form below. Come with questions. We're still not done with this section, so it's a big one. So be ready. All right, thanks, guys.